So this video is all about solving equations where you have variables on both sides of the equal sign, which is something that we haven't seen yet in all the work that we've been doing on working equations so far in class. And so in order to understand how it is that we work with variables on both sides of the equation, we have to go back to what those two major goals were when we were solving equations in the first place. The first, which we've been working on consistently, is the idea that the equation needs to stay in balance. And we do that by showing the work on both sides of the equation. Those go back to the properties of equality. We can add the same thing to both sides as long as we show that we're adding the same thing to both sides. We can subtract the same thing from both sides as long as we show that we're going to subtract the same things from both sides. Same thing with multiplication and division. That part is incredibly useful and is going to be incredibly important for solving equations with variables on both sides. But the other important thing that we keep in mind when solving an equation is our goal, which is to isolate the variable, which in this case means to compress the variable so that all terms that involve the variable are on one side of the equation. So if we look at something like 3x is equal to 2x plus 12, what we notice is that we have a 3x on the left-hand side and a 2x on the right-hand side. And so in order to actually solve this equation, we need to move all of those variable terms over to one side. And we do that in the exact same way that we have done equation solving for the entire time, which is to add, subtract, multiply, or divide to move the terms from one side to another. Here, and this is going to seem very different from what we've done before, we're not interested in dividing by 2 or 3 or anything like that. We want to entirely get rid of the 2x term, for example. So we're going to take 2x away. There are two x's on the right-hand side of the equation. We want to get rid of them, and we're going to move them onto the left-hand side. There we have 3x is equal to 2x plus 12. Take 2x's away. On the left-hand side, end up with x. On the right-hand side, end up with 12. Let's take a look at that using an example of junior mince boxes and goldfish. Here, we've taken our equation 3x equals 2x plus 12 and represented it with physical objects. X's are junior mint boxes. Numbers, constants, are goldfish. So on one side of the equation, on the left-hand side, we have 3 junior mince boxes. On the right-hand side, we have 12 goldfish and 2 junior mince boxes. So our goal here is to figure out how many goldfish can be represented by one junior mince box if the two sides are equal. Well, when we look at it in this physical format, this very visual format, we can see, well, the easiest thing to do is we just take 2 junior mints away from both sides. Because there are 2 junior mince boxes on both sides. It doesn't matter what they are, they represent the same thing. Let's get them out of there, and now we have 1 junior mince box is equal to 12 goldfish. From the point of view of equation work, that's the same as taking 2 x's away from both sides. Let's take a look at another example of a multi-step equation that we could solve with variables on both sides. So here we have one slightly different format. 7x plus 7 is equal to 5x. Let's go ahead and we can do it either way. One way will just be a little bit faster, but let's move all the x's onto the right-hand side, which means we want to get rid of this 7x here. Well, we can subtract that 7x from this side, and that's going to completely get rid of the term. Again, this is different from what we did before, where we had an x term and a coefficient we would need to divide so that we could keep the x on the side that we want. But in this case, we want to move all of the x's onto the right-hand side. So we use addition or subtraction, like we do with taking away 2 junior mint boxes, to move them all onto one side. That is left with a 7 on the left-hand side and a negative 2x on the right-hand side. Now we're back to familiar equation solving. Divide by negative 2 and get x is equal to negative 7/2 or negative 3.5. Let's take a look at that in one more circumstance. So 4x plus 8 is equal to 2x plus 4. Here we have some constants on both sides as well as some variables on both sides. So we're going to have to deal with both of them eventually. You might, looking at this so far, prefer to move all the variables onto one side so you end up with a positive coefficient, and that is totally fine. So let's do that. That means we're going to take the 2x and we want it to be moved over to the other side. Well, in order to take 2x away from the right-hand side, we're going to subtract it away, again, removing 2 junior mince boxes from both sides. Take 2x away from the left-hand side, and we end up with 2x, because 4x minus 2x equals 2x, plus 8 is equal to 4, because the 2x's just cancel. Now we can take 8 away from both sides. This is a familiar process that we've seen before. Get 2x is equal to negative 4, and then divide by 2. I'm not going to show it here because I'm running out of space on the bottom, to get x equals negative 2. But in order to do that, all we would have to do is just divide by 2 on both sides and get x equals negative 2. If it still is a little bit new and a little bit confusing, that is totally okay, because this is a whole different style of equation solving, a lot more details, and a lot more different options of things that we can do than the types we have done before. But I've got 3 pages of practice problems for you, 2 on each page. Go ahead, pause the video, do the best you can with these 2 problems here. Come back when you have gotten your solution and you're ready to see the answers and move on. So in the one on the upper left, we're going to subtract 1x away from both sides. The right-hand side is left with 18. The left-hand side becomes 6x, and then we can divide by 6 to get x equals 3. On the right-hand side, we can actually add 2x to both sides. We've got a minus 2x right there, so let's add, because addition is the inverse of subtraction. 4x plus 2x is 6x. 30 is left on the left-hand side, and then we're going to divide by 6. To get x is equal to 5. Another page, 2 more problems. Go ahead, pause the video, solve these equations, come back when you're ready to see the processes and the solutions, and move on to the last page. So on the left-hand side of this equation, we're going to take away 2k, going to try to keep all of the variables with positive coefficients when we can. That leaves 81 on the left-hand side and 3k on the right-hand side. Divide by 3. To get 27 is equal to k. On the right-hand side, we have a few different options of what we can do. Let's add 7x to both sides because we see a negative 7x. That's going to give us 15x plus 11 is equal to negative 19. Very important. That subtraction sign comes with it. It's a negative 19. Now we'll subtract 11 from both sides. End up with 15x is equal to negative 30, and divide by 15 on both sides to end up with x is equal to negative 2. One last page, 2 more problems. Go ahead, pause the video, see what you can do with these. Remember what it is that we need to do when we see a distributive property type of problem in an equation. Solve these equations, come back when you're ready to see the solutions, and end the video. So on the left-hand side, as with both of them, we're going to need to distribute first. So 2x plus 7, or plus 14 rather, is equal to 9x. Take 2x away from both sides, and we end up with 14 equals 7x, and then divide by 7 to end up with x equals 2. On the right-hand side, we're going to distribute again. 3x minus 15 is equal to negative 3x. We can move the variables to whichever side we want. I'm going to show you what happens when we move everything to one side. It is a little bit of an extra step, but some might find it easier. We can add 3x to both sides, or we can subtract if we want to clear it from the other side. And then we end up with 6x minus 15 is equal to, well, there's nothing on the right-hand side, so we end up with a 0. Now we're going to add 15 to both sides to end up with 6x is equal to 15. Then we can take the final step of dividing by 6 to get x is equal to 2.5. 2.5, 5 halves, whatever it is that you want to show it there. So solving multi-step equations when you have variables on both sides acts exactly like solving equations when you have variables on one side, except the extra step that we need to take of isolating the variable, putting it all on the same side, can be thought of exactly like solving equations based in junior mints and goldfish. Taking away 2x from both sides leaves 2 fewer x's, or 2 fewer junior mint boxes on each side. So if you have a 7x that you need to remove, you can subtract a 7x. Now all of the operations are in play when it comes to variables and their coefficients, but use the same processes, put all the variables on one side, all the constants on the other using that add, subtract, multiply, and divide that we've seen before, and you will end up at the correct solution.